Welcome to lecture series on design and analysis of algorithm. In today's lecture series, we are going to discuss about an algorithmic problem solving technique called as divide and conquer. So under divide and conquer, we are going to discuss about the problem multiplication of largest integers. So by default, how do we multiply two integers? So initially we will multiply the ones place of one number, one integer with all the other digits of other number. Then we will multiply the tens place of another of one number with all the other digits of other number. So we will add these two results. The final value gives the multiplication value of those two integers. So this is how traditional multiplication happens. Now, consider you have four-digit integers to multiply with. If it is one-digit integer, multiplication will be an easier process. If it is two-digit integer, it is quite difficult when compared to one-digit multiplication. And if it is three-digit, again it is bit complex. And if it is four-digit integer, again the difficulty level increases. So with the number of digits increasing, the multiplication process becomes more complex, right? So as you can see in the previous step, when we are multiplying two-digit integer, it has only two steps. However, here when we are multiplying four-digit integers, totally it is taking four steps to find the final answer. So this goes on when you are multiplying 16-digit integer, the number of steps will be more. So when the number of digits increases, the number of steps also increases, and it is totally a time-consuming process. So consider a problem where you want to multiply a two-digit integer. So it is represented by array of digits such as the array A contains digits A1, A2 to AN, and array B contains the digits from B1, B2 to Bn. So traditional multiplication happens like A1 is multiplied with A2, again A1 is multiplied with uh, A3, A1, A3, and it goes on like AN is multiplied with BN, B2, and Bn. So the final answer you will get like this, right? So here is an example. You have two-digit integers. A is equal to 23 and B equal to 14. You can represent it like this. 2 belongs to the tens place, so 2 into 10 power 1, and 3 belongs to ones place. So 3 is multiplied with 10 power 0. Similarly, in 14, 1 belongs to a tens place, so 1 is multiplied with 10 power 1, and 4 belongs to ones place, so 4 is multiplied with 10 power 0. So upon multiplication, you will multiply like 2 is multiplied with so 2 plus 3 is multiplied with 1 plus 4. So the final answer you will be getting is like this. Initially 2 into 1 into 10 power 2 plus 2 into 4 plus 3 into 1 into 10 power 1 plus 3 into 4 into 10 power 0, and the final answer is 322. So the last formula that we have seen, it uses a four-digit multiplication. So the time complexity is n square. N represents the numbers that you are multiplying. Here we are multiplying two numbers. So it is n square. So here a total number of multiplication that happens is three multiplications in total, right? So for a two-digit integer, a equal to a1 into a naught and b equal to b1 into b naught, the product c can be computed by C equal to A star B, which is equal to C2 into 10 power 2 plus C1 into 10 power 1 plus C naught, where C2 is A1 into B1, which is the product of their first digits. So now this C naught value is computed like C naught is equal to A naught into B naught, which is a product of their second digits, and C1 is computed by C1 equal to A1 plus A naught into B1 plus B naught minus C2 plus C naught, which is the product of the sum of A's digit and the sum of B's digit minus the sum of C2 and C naught. So now let us see how to apply divide and conquer a strategy in solving this problem, which is multiplication of largest integers. So in general, when you want to multiply a two-digit integer a and b, where n is a positive even number, so the first half of the a's digit is denoted by a1 and second half of a's digit is denoted by a naught. Similarly for b, the first half is represented using b1 and second half is represented using b naught. So in these notations, we can finalize like uh, a equal to a1 into 10 power n by 2 plus a naught, and b is equal to b1 into 10 power n by 2 plus b naught. So here as an example, the value of A is 2135, that is 2135, and value of B is 4014, which is 4014. So according to the previous discussion, when we divide A into A1 and A naught, A1 is equal to 21 and A naught is equal to 35. And similarly, in case of B, B1 is equal to 40 and B naught is equal to 14. So upon applying divide and conquer strategy, let us see how this divide and conquer is applied. So the formula to compute the value of C is equal to A star into A1 star into B1 into 10 power n plus A1 into B naught plus A naught into B1 into 10 power n by 2 plus A naught into B naught. So here C2 is the product of their first halves. So C naught is a product of their second halves. So here, instead of using 4 multiplication like traditional way, we just need to compute 3 multiplication. Here only 3 computation is required. So the number of multiplication compared to traditional multiplication is reduced. That is why divide and conquer is more effective when you want to multiply largest integers. The same method can be applied for computing the products of C2, C0 and C1. So this is a recursive algorithm for computing the product of n-digit integers. So this recursion stops when the n value is equal to 1. So here the multiplication of n-digit numbers requires 3 multiplications of n by 2-digit numbers. So the recursion of the number is equal to m of n equal to 3 into m of n by 2 for n greater than 1, and m of 1 equal to 1, which is the initial condition or the stopping criteria. So this can be solved by using backward substitution. Upon substituting n equal to 2 power k, you will get the answer like m of n is equal to n power 1.585, which is nearly equal to n square, and the time complexity is order of n square. So here are some of the assessment questions for you to have better understanding. So first one is, what is the running time of multiplication of largest integer using divide and conquer? So we have seen in the previous slide. So the time complexity is order of n power 1.585. So it is not 583, it is 1.585. So which is equal to order of n squared. So option is D. So can we solve largest integer multiplication using brute force approach? Answer is no. We solve it using divide and conquer strategy as we have seen earlier. So hope you understood how to multiply the two integers using divide and conquer strategy. So in the next video, we will discuss some other problem types under divide and conquer. Thanks for watching.